Hey guys, this is Coach Brian. I'm going to be going over questions 1 through 4 on the 6.5 notes. This is all regarding trigonometry applications, so every question will be kind of like a real world example type problem. So, first instructions say to draw a picture. That's going to help you a lot if one isn't provided. It also says to round the side length to the nearest hundredth and the angles to the nearest thousandth of degrees. So you need to make sure if you're using a calculator that it's in degree mode. And then as we sketch it, we'll be forming triangles in our pictures. So first thing we've got, it says a ship is passing a lighthouse. So if we have our little lighthouse on here, you don't have to draw your pictures super detailed every time. I just enjoy it because I used to do it a bunch when I was a physics teacher. So if we've got a lighthouse out here and a ship going by, that ship is moving, the lighthouse is not, so it's important to put yourself in the correct point of reference for a problem. So point of reference, we'll say there's an observer over here in the lighthouse, okay? So the first thing says that at its closest point to the lighthouse, the shortest distance between any 2 points is a straight line. Okay, that's just a good thing to know for life. The shortest distance between any 2 points is a straight line. So when you are looking at this boat, I know I can move mine around and drag it around and whatever, but when you're drawing your picture, the first image will be, or the first kind of point will be when the boat is at a straight line distance from the lighthouse. So that's 2,400 meters. Now, like we said, the boat is going to continue moving forward, and the lighthouse is obviously staying still. It's a lighthouse. So it says the ship continues on its path. At the next measurement, it's 2,650 meters from the lighthouse. Key term right there, from the lighthouse. Am I measuring from where the ship was? No, I'm measuring from the lighthouse. So if I'm measuring from the lighthouse, that will pertain to the hypotenuse of this triangle. So now we can kind of map everything out. We've got our triangle here. We've got 2 sides of it. And we're looking for 2 things. We are looking for what angle did the ship's bearing from the lighthouse change, and how far did the ship travel between the 2 measurements. So what we're looking for is the angle from the lighthouse. So initially, the boat was straight out from the lighthouse, and then it was out past the lighthouse. So when we are looking for our angle, we are looking for this angle right here. So we're going to make that our theta. Okay, that's our unknown angle. Then the next thing, how far did the ship travel? That's going to be our horizontal distance this way. How far did the ship travel from point A to point B going forward? So we can attack this 2 different ways, but we'll just go ahead and go in the order that they want us to. We will solve A first, and then we'll solve B second. So the first thing that they're asking us is, what is the angle? So looking at this image, we have 2 sides and an unknown angle. So when we're looking for an unknown angle, we're going to use an inverse. So let's set up what we know. From this angle, we know the side next to it. That is called the adjacent. And we know the side across from the 90. That is called the hypotenuse. So we know the adjacent and the hypotenuse, we would ask ourselves which trig function uses those two things. So that is cosine. Cosine of theta is going to be the adjacent over the hypotenuse. So that means cosine theta is the adjacent side over the hypotenuse. Now, we are looking for an unknown angle, which means on both of these sides, I need to perform some kind of operation. So the first thing I want to do is I want to cancel the cosine so that I can isolate theta. So if I want to cancel something or undo something or reverse something, I need to use its inverse. And whatever I do to one side, I need to do to both sides. So on this side, these will cancel, and I'm left with theta equals the inverse cosine of 2400 over 2650. And that gives me, 25.088 degrees. Now, it's important to go to 3 decimals because that is what we were instructed to do. Round angles to the nearest thousandth. So now that we know theta, we can actually find this missing side a couple of different ways. So the first thing we could do, I'm going to show you 3 different ways just to show you options. The first thing we could do is use the Pythagorean theorem. And since this is like a leg, we could say that b, the leg, equals the square root of c squared minus a squared. So what this would look like, actually plugging in numbers, this would look like the square root of 2650 squared minus 2400 squared. So that's one way you could solve. The second way you could solve is you could say, okay, that's the side opposite of my angle. So you could say that sine, maybe my pen will work, sine of 25.088 equals, and you could say the opposite over the hypotenuse. And when you rearrange that, multiply both sides by 2650, you would get 2650 times the sine of 25.088. So that's one option there. 2 ways so far that you could do the same thing. There's option 1 and option 2. And then there's actually a third way you could do it. You say, I'm looking for the opposite side, and I know the adjacent side. And so what you could actually do is you could use tangent to also find theta. You could say tangent of 25.088 equals, and it equals the opposite that we don't know over the adjacent. And so what you'd do is you'd multiply both sides by 2400, and you would type that directly into your calculator. Now, my point in doing this is to show you that there are multiple ways to come to the same conclusion while we're doing this, and there's multiple strategies that you can use. And for every single one of these, your answer should be somewhere around 1123.61, somewhere around there. All 3 of them will give you the same answers because they are all different ways of solving for that missing side of the triangle using all of the reference information that we are already given. Now, for the rest of these problems, I probably won't go into all the options you can do, but just know I may show something, and it's probably not the only way to find the correct answer. I'm going to shrink this just so it's not all over the screen in my next one. All right. Question 2 says, a person on the edge of a canal observes a lamppost on the other side, with an angle of elevation of 12 to the top and an angle of depression of 7 to the bottom. The person's eye level is 152 centimeters high. So a lot of key terms in here. The first one being the person's eye level, okay? That's what we call a line of sight. It's always important to put yourself into the point of reference of the problem. So if you're this observer, the line perfectly perpendicular from their eyes, straight out from their eyes, is their line of sight. Their eyes are 152 centimeters above the ground. So that confirms for us that the bottom part of this lamppost is 152 centimeters. Now, if these two angles were the same, then this would also be 152. But they're not the same, so they can't both be 152. So what we're going to have to do is progressively build on the information, calculate one thing at a time, and see if we can figure out the two things they ask us for, which are the width of the canal. So we want to know how wide is the canal. And we want to know the total height of the lamppost. Right now, we know part of the lamppost. We do not know the whole lamppost. We want to know the entire thing. So, next two terms that you need to know are angle of elevation and angle of depression. An angle of elevation is always going to be, from a point of reference, an angle that goes up, opens up, elevates. Whereas an angle of depression will be an angle that opens down or depresses. So in this image, from the line of sight, the angle of elevation would be the angle looking up, and depression would be the angle looking down. Now, the first thing that they ask is to find the width of the canal. If I look at my image, the width of the canal also happens to be the distance from the person's eyes to the lamppost. So those distances correspond. And from my two angles, from both of them, if I go from the 12 or I go from the 7, this is the adjacent side. Okay, this is the adjacent side of these triangles. Now, in both triangles, I am looking for the side across from the angle, which is the opposite. So, which trig function uses opposite and adjacent? That would be tangent. So, ultimately, I need to try to find the adjacent first, then find this opposite. I need to find the adjacent first, then the opposite. So let's start with the adjacent. I need to use the triangle that I know the most information on. For this starting one, that is this bottom triangle where I know the angle is 7, and I know that one of the sides is 152. So let's just kind of bump over here. You don't have to do this on your paper, but I'm just going to kind of re-sketch it, removed from the image. Okay, so 7 degrees, 152. I need to find this side. So I have the opposite. I need the adjacent. So the way you would write this out is you would say the tangent of 7 degree, of this 7 degree angle equals opposite over adjacent. Now, when you are solving these, you could rearrange it algebraically, or you could recognize, like, it would be really nice if these or flipped. And if you want the ratio to flip, you need to use the reciprocal. So what we could say is that the cotangent of 7 degrees equals adjacent over opposite. Now that's nice because I can now multiply both sides by 152. And if you're using Desmos or a calculator with all the functions, you can type that directly in. However, if you don't, there's still a way to make it work. When we learned our reciprocals, we learned that if you don't have the button for it, you can just write the reciprocal in its place. And so you can type this directly into your calculator, and you will get that the side, the adjacent side in this image is 1,237.941 centimeters. Now the instructions say round the side lengths to the nearest hundredth. So since that is a 1, we can get rid of that guy. And that's our adjacent side. Now, how does that help us? That helps us because now in our image for our second triangle, 12-degree triangle, I now have an angle and a side. And I need to know the opposite. So, need to know the opposite. I have the adjacent. Tangent uses opposite and adjacent. So you could say that the tangent of 12 equals opposite over 1237.94. And now this one doesn't need to use any reciprocals or be rearranged. I can just multiply both sides by 1237.94. You can type this directly into your calculator, and you will get that the opposite side is 263.132 centimeters. Now, looking at our image, that's this part. Is that the total lamp post? No, it's just the top of the lamp post. The total lamp post is when I take 263.132 and I add 152 to it, and I get 415.132 centimeters as my total height of the lamp post. So we got the width of the canal, and we got the height of the lamp post. Now, let's keep moving. A swimming pool is 3 foot deep in the shallow end. 3 foot deep in the shallow end. The bottom of the pool has a steady downward drop of 12 degrees towards the deep end. If the pool is 50 feet long, how deep is the deep end? Let's sketch this out real quick. Swimming pool at the shallow end is 3 feet deep. The pool itself, 50 foot long. From the shallow end to the deepest part of the deep end, it declines at 12 degrees. So what you need to do is you need to actually separate this into two shapes, because your angle of decline, angle of depression is 12 degrees. And so we've got a rectangle and we've got a right triangle. And we know that this part from there to there is 3 feet. We know that this part is 50 feet, which means my little purple on here is also 50 feet. I need to find what this side is so that I can find the total depth of the pool. need to find the total depth of the pool. So once I've got that in place, I am looking for the opposite, and I've got the adjacent. So I'm going to be using tangent. Tangent 12 equals opposite over adjacent. And I can multiply both sides by 50. I can put 50 tan 12 into my calculator, and I get 10.627 feet. Now, that is just this portion. So I have to go over to that 10.627, and I have to add my 3 feet for a total depth of 13.627 feet. Now this last one, and I think the bell will probably ring while I'm recording this, so just bear with me. It says a 60-foot drawbridge is 24 feet above water level when it's closed or down. So we have a drawbridge. When it is down, like all the way down, it is 60 feet and it's 24 feet above the water. So these two sides would be 24 feet, okay? Now, when open, the bridge makes a 33-degree angle with the horizontal. How high is the tip of the bridge, point P, when it is open above the water? So we're looking at how high is point P above the water when the bridge is open. So we need to find this missing side, and then we need to add the 24 to it so that we get the total height. Now, this bridge, when it's down from here to here, is 60 feet, which means when it's up, the hypotenuse is 60 feet. You notice it doesn't reach all the way anymore because the bridge isn't getting longer as it raises up. It's still a 60-foot bridge, but when it's up in the air, it's now the hypotenuse of this triangle right here, okay? So we need to find this first. And we have, from our 33-degree angle, we are looking for the opposite, and we have the hypotenuse. We're looking for the opposite, and we have the hypotenuse. That means we're going to use sine. So we could say that the sine of 33 equals a number I don't know, but I want to know, over my hypotenuse of 60. So we'd multiply both sides by 60. And when this bridge is up in the air, the opposite side is 32.678 feet. Now, 32.678. That is just from here to here. It wants to know the height above the water. So we need to add 24 to that so that we get our total height above the water, which is 56.678 feet. So that's the first one, 56.678 feet. Now, it says when the bridge is open, what's the distance from P to Q? So this one is a little trickier, okay? We're now looking for this distance right here when the bridge is open. So we kind of want to approach this from a different view, okay? We are looking for a little segment of, what's missing right here. So what we need to do, follow with me here, okay? You know that when the bridge is down, this distance that I'm highlighting in purple, when the bridge is down, this whole distance is 60 feet. We want to know how much, or how the bridge, we want to know what distance it's short when the bridge is up in the air. I want to know how much distance is there from the end of that bridge to where it would normally touch down if the bridge was down. And so we're looking for this little segment right here. Okay, we're looking for this little segment right here and right here. Those correspond with each other. So if we can find this distance while the bridge is up, we can subtract it from 60, and it will leave us with this little bit right there. It will leave us with that little bit. So essentially what we need to do is we need to find from 33, we need to now find the adjacent side, okay? So we have the opposite, we need the adjacent. And so we can say the tangent of 33 equals 32.678 over the adjacent. And we need the adjacent, okay? We need the adjacent. So this is one of those ones like earlier where it would be really nice if I could flip this. And I can flip it by using the reciprocal of tangent. So I can use cotangent of 33, and then I've got the adjacent over 32.678. And you're asking, why would you want to do that? It's because I want to multiply this denominator out of there, get it over to the other side, and then I can put this in my calculator. Now, again, if you run into the problem of, I don't have a cotangent button, use the reciprocal. So you can type directly into your calculator 32.678 times 1 over the tangent of 33. And when you type that into your calculator, which I'm doing right now, so bear with me, you will get 50.32. So what does that mean? It means when the bridge is up, I'm going to erase a little, right? When the bridge is up, from here to here, when the bridge is up, is 50.32 feet. When the bridge is down, from here all the way over here, that's 60. And so if I want to know what this little portion is right from there to there, how much is this? I need to take 60 minus 50.32, and that will give me the little remaining distance of 9.68 feet. All right, sorry for the bell interruptions. Hopefully this helps you with 6.5 and helps you get ready for your upcoming quiz. Thanks.